Hello and welcome to this episode of Math with Martinez. In today's video, we are looking at our very first skill in this unit. This unit is all about functions and their graphs. So in this video, the skill that we are looking at is the very first skill, FG1. And what that skill is all about is describing the symmetry of graphs of both even and odd functions. So let's go ahead and get started. I want to begin by talking about the types of symmetry that we can have for function graphs. The very first type of symmetry that we can have is called line symmetry. For line symmetry, the graph can be folded along a line. It's being folded along a line so that the two halves match each other. So in this little picture, imagine our line going right down the x-axis. You see that folding line? On either side of that line, you have these little curves that are perfect mirror reflections. For that second function graph, the line that you would fold along would be your y-axis. And in folding along that line, you have those two little pieces that are perfect reflections of each other in this line. There is another type of symmetry, and it is called point symmetry. In point symmetry, the graph remains unchanged when rotated 180 degrees about a point. So if you rotate it 180 degrees about a point, like this point right here, if we were to spin that graph 180 degrees, rotating around and rotating around, the graph will be exactly as it was. It is unchanged when you rotate it. So let's go ahead and reflect here in the bottom half. It says that the x-axis and y-axis, like we saw above, are common lines of symmetry. And the origin, like we saw here, is a common point of symmetry. So how do we test for symmetry? The graphical and algebraic tests can both be used to determine if the graphs of a relation is symmetric to either the x-axis, y-axis, or the origin. So let's talk about if we have x-axis symmetry. For every point x and y on the graph, the point x and opposite of y is also on the graph. If you look here, here is the point x and a positive y. And right down here reflected is the point x and the opposite of y, the negative value of y, but the same distance away from the x-axis. And so how do we test that algebraically? We can replace y with the opposite of y, and it will result in the same equation. Now, we can also have y-axis symmetry, and for every point x, y on the graph, the point opposite of x, y is also on the graph, which you can see modeled above. Here is a point x, positive x and positive y, and it is reflected here where the x is now opposite and the y is still at that same height. We can test this algebraically by replacing x with the opposite of x, and it will have that equivalent equation. Finally, we also have the origin symmetry. And to test that graphically, for every point x, y on the graph, you will also have the point opposite of x and opposite of y. You can see that modeled here. Here we have a point x, y, both positive. And then it is also reflected right down here, the same distance, but in the opposite direction, so that's opposite of x. And instead of a height of positive y, it's a height of negative y. So how do we test that algebraically? We do so by replacing y with the opposite of y, and also x with the opposite of x into our equation, and we should have an equivalent statement. Now, the whole reason for this lesson is to be able to, like we said at the beginning, achieve that goal of describing the symmetry of graphs that are both even and odd functions. So now let's connect these big ideas. What is an even function? A function is called even if it is symmetric with respect to our y-axis. Oops, that's not the blue I want. I want that bright blue. There it is. Like we saw here above. And our algebraic check. How do we check that algebraically? Well, like above, f of x should result in the same thing if we take the opposite of x, it should be the same thing as the original function, like we saw here. If we replace x with opposite of x, we should have that exact same result. And a function is an odd function if it is symmetric with respect to the origin. In our algebraic check there, how do we check that it is in fact an odd function? Well, if you take f of the opposite of x, you should get the opposite result of your function, meaning the output will be opposite. And there you have it. That is what we saw above. So, ladies and gentlemen, now with all of that, we have kind of a big overview of the types of symmetry, how to test them, and then how to determine if, based on our tests, if they are even or if they are odd. So let's try and do just a couple examples together. We're going to use the graphs to determine if the relation is symmetrical with respect to the x-axis. Oops, let me go and highlight that like we did previously. If it is with respect to our x-axis, our y-axis, or the origin. So let's use our graph to determine that and then confirm our results algebraically. So here we go. What kind of symmetry does this graph appear to have? Here is my curve. Where does it seem to be that the line could fold and create two symmetrical pieces? Well, if you said the y-axis, you are absolutely correct. That y-axis is where we could fold and see the same on either side. Now let's check that algebraically. What we said is that if it is y-axis symmetry, we should replace x with opposite of x. We should replace x with the opposite of x, and it should result in the same equation. So let's go ahead and try that. I'm going to take my equation, but replace x with the opposite. So instead of x, I'm going to say opposite of x to the fourth, and 4 times opposite of x squared. Now, ladies and gentlemen, what happens when we take a negative value to the fourth power? When we take a negative value to the fourth power, it will just be positive. So it'll still just be x to the fourth. And what happens when we take a negative and square it? When a negative is raised to the power of 2, it's still just positive. So there you have it. It is the same equation as above. What about this next one, example number 3? What kind of symmetry do we seem to have here by observing the graph of this little oval shape, this little elliptical looking thing? What kind of symmetry does that seem to have? Well, if I were to fold right here along my x-axis, then it would be a perfect reflection. This point would reflect down from that positive y value to that negative y value, but on the very same position of x. To check algebraically, we will go ahead and replace y with the opposite of y. And when we do so, here is the result. We've got 4x plus 3 squared plus opposite of y squared equals 16. Oh, well, look at that. Once again, we have that our negative quantity is being squared, but a negative y squared is just the same thing as y squared. So that is the equivalent, and so it is in fact x-axis symmetry. All right, couple more examples here. In these examples, we're going to determine algebraically if our function is even, odd, or neither. If it is even or odd, we're going to describe what kind of symmetry that is. All right, so if it is even, it is symmetric with respect to our y-axis. If it is odd, it is symmetric with respect to the origin. So how can we determine this? Using that algebraic check, let's see what happens. Let's see what happens when we substitute in the opposite of x. If we substitute in the opposite of x and it gives us the same, then it is even. But if we substitute in the opposite of x and it is the opposite of what my function was, it will be odd. If it is something altogether different, it is neither even nor odd. Let's go ahead and see what happens here. If I take this function at the opposite of x, then I'm going to be taking opposite of x and cubing it and subtracting the opposite of x. When I do so, a negative cubed is going to actually be a negative value cubed. And when I take a negative and distribute that into the negative x, that's going to be a positive x. So now let's compare. Let's compare how is this statement when related to the original. Are they the same? No, not the same. Is it that everything is made opposite like we see here? Is my function opposite of the original? It does seem to be true of that. Look, guys, it was a x cubed, but now it is a negative x cubed. then a negative x term, but now that is a positive x term. So what does that imply? If everything is opposite, then it is an odd kind of symmetry here. We have an odd function. This is an odd function. And odd functions are symmetric about the origin. So we have some origin symmetry. All right, well, what about 9? What about example number 9? What happens when we look at this function at the opposite of x? Can you guys decide what kind of symmetry do we have here, or do we have any at all? Go ahead and try this one on your own. All right, well, you would be substituting x, negative x, and cubing it, minus a negative x squared, minus a 2 times a negative x. A negative cubed will be negative. Then you're subtracting a negative squared, which is going to be positive, but we are still subtracting that. And then your negative 2 times a negative x is a positive 2x. So let's compare. Positive term, negative term. Negative term, negative term. Oh, those are the same, but the first ones were opposite. First ones were opposite of each other, but now these are the same. Guys, it doesn't seem to be following either one of these. It's not exactly the same as the original, and not everything is made opposite. This implies that we have that this is not a even or odd function. It has no kind of unique naming of it. It's not even or odd. So sad. We'll just put none. Lastly, will you guys try problem 11? Problem 11. What kind of symmetry do you see there? Or is there none at all? All right, well, when we take our function at the opposite of x, that's negative 8 over the opposite of x. Negative over negative is going to give us a positive 8 over x. So initially it was negative 8 over x, and now it is positive 8 over x. It's not the same as the original, no, but it is in fact the opposite. So what we have is odd, a function that is odd and symmetric to the origin once again. And that is all for our video today, guys. If you had any questions about our even and odd functions and how we can test graphically or algebraically for those symmetry lines, let me know now. Thank you, guys. Well, until next time, as always, stay fired up.